All right, we did multiplying and simplifying radical expressions. We're now going to do some dividing with radical expressions. And then also one of the famous things that we do is rationalizing denominators or numerators. So we can do division. And again, the key is, what is our index number? It must be the same in order to do this. So if we have it like this, it can be separated. If it's like this, it could be like that. And that's what they're illustrating. You must have the same index number. Okay, so let's jump right in and do some of these. So, again, mentally, we're thinking of doing this. The square root of 49 and the square root of x to the fourth. This is going to become 7, and this becomes x squared. You can skip this step, but if you need to write it out, that's okay. Now again, as we do this, sometimes you may have to write it out. Third root. This is from our previous section. And the third root of n to the third. So here this is going to be 27. We did this before. And a 3. M to the third. M. Okay, we have it set up. And this is going to be 3m. The cube root of 3m all over n. So again, probably you would have to write this intermediate step here. And that's how we did it. And this one, they're dividing it into two parts, then teasing the top apart, putting your perfect cubes under one radical sign, whatever is left over, and then simplifying. Remember, you can always rewind the tape. All right. Now, this one is interesting too. So as we do this one, we can put it all under one radical sign. Now we can actually do this division, which gives us then 16, which gives us, so we did, and we got that. Okay, see, they took the 1/2 out, put her on the correct B. So there is a 1 there. So there's where we get our 1/2 from. I'm going to put the rest of this under a common radical sign, and it simplifies to this. Now, what is the cube root? Do we have perfect cube roots in there? And we do. So we're going to tease this apart into this, and y to the 5th is y to the 3rd, and what's left over, y to the 2nd. Now when we take the cube root of 8, we get 2. And notice what's going to happen here. These 2's will cancel out. And there is our final answer. Okay, we're now going to rationalize denominators or numerators where there's just one term. And the word rationalize, you might wonder, well, what does that mean? Well, in many cases we have irrational numbers in our denominator, and we want to make them a rational number. So this is the technique we're going to show you. So in letter A, we want to do our denominators. So we're going to set it up as the square root of 5 over the square root of 7. Now, I'm allowed to multiply anything by 1 without changing its value. So if I multiply my denominator by the square root of 7 and my numerator by the square root of 7, 7 over the square root of 7 over the square root of 7 is 1. But notice what happens now. I get the square root of 49 in my denominator, and I get the square root of 35 in my numerator. And what is the square root of 49? Well, that's going to be 7, and the square root of 35 on top. So where originally we started off with an irrational number, by just squaring it, I made it into a perfect square that then became a rational number. I have rationalized my denominator. Now, as we set this one up, it's the third root of 3 over the third root of 25. And you might say, well, what do I multiply it by? Again, it wants to be a 1, but which one? Now, notice that 25 is 5 times 5, so to make it a perfect cube, I only have to multiply it by the cube root of 5. And there's the artisan or creative part of what number do you pick. So this then becomes the third root of 15 on top, and this becomes the third root of 125, which is now a perfect cube, which becomes 5, and then the third root of 15. So what have I done? I've taken an irrational number, and by treating it a certain way, multiplying it by 1, I'm not changing the value of the fraction, but I've rationalized my denominator. It's gone from irrational to rational. There's A, and there's B. And they're doing it just a little different way, which is okay. The results are the same. Okay? All right, so let's do this one. So we still want to rationalize denominators, so this is the square root of 5, and this will be the square root of 3x. And what will I multiply it by? Well, this will be the square root of 3x, square root of 3x. So this now becomes the square root of 15x over 3x. Remember, this became 9x squared, and the square root of that is this. Now, keep in mind, if this is an index number 2 and this is an index number 2, then whatever is in the radicand, by squaring it is what we're doing, it just becomes the radicand. All right, for b, now this one doesn't have a radical on top, but it's the third root of 4xy squared. So what form of 1 will we multiply it by? Well, this is 2 times 2, so for the number part would have to be a 2. This is x to the first, so that'll be x to the second. This is y to the second, so I just need another y. And then I do the top the same. 2x squared y. So then this just becomes 3y, the cube root of 2x squared y, all over now. Since this is going to be 8, which will be a 2, x, y. Now notice something here. I now have a y that's outside. I can cancel out these y's. So my final answer then will be 3, the cube root of 2x squared y, all over 2x. All right, some of these will get challenging. And A was good. Now B, again, we had to see what form of 1 are we going to multiply it by. This is a 1 here, but it makes our denominator a perfect cube. There it is. So we take the cube root of that. And notice now you do have the common y's that will cancel out. Okay. Yeah, in calculus, those of you who are going to take it, sometimes they need to rationalize the numerator. So it's the very same process, except instead of the denominator, we want to rationalize the numerator. So let's take a look at it here. So this will be the square root of 5 over the square root of 3. Now the one that we're going to choose will be so that we rationalize the numerator now. So this becomes 5 over the square root of 15. And we have this. I guess I'll just use this right here. Save a little time. And what do I multiply this by? Well, it has to be the cube root of 3 times 9 will give me 27y. That'll give me a perfect cube there. So this is going to be 27. Oh, I'll write it out here. 27y cubed. This is now a perfect cube. And this is going to be the cube root of 36xy. So my numerator now becomes 3y as I take the cube root of each of these, and my denominator is this. Okay, let's go on here. There's A. And again, the one that we're choosing, in this case, needs to rationalize the numerator, and we get that. Okay, that was short.